2-7, solving proportions. So our objective for this section is to solve and apply proportions. In the last section, we talked a lot about ratios. Now we're going to talk about proportions. And our essential understanding is that if two ratios are equal and a quantity in one of the ratios is unknown, you can write and solve a proportion to find the unknown quantity. Okay. So a proportional relationship can produce an infinite number of equivalent ratios. Any two of these can be used to write a proportion. A proportion is an equation that states the two ratios are equal. For example, A over B is equal to C over D, where B is not equal to 0 and D is not equal to 0. Both of the denominators can't have a denominator equal to 0. That is a proportion. We can read this as A is to B as C is to D. And as long as we have any numbers, we can make something that's true. 2 over 3 is the same thing as 6 over 9. If we reduce 6 over 9, we get 2 over 3. Okay? That can also be equal to any numbers. So that's 8 over 12, right? So we can set up a proportion with any types of equivalent ratios. What we're going to be looking in this section is to figure out how to solve equations that look something like that. Okay? So let's look at our first proportion here. 7 over 8 is equal to m over 12. And let's solve this using the multiplication property. So I have 7 over 8 is equal to m over 12. Well, my variable m is divided by 12. So what I can do is I can just multiply both sides of this equation by 12. Those will cancel out. And on the left-hand side, we would have 12 times 7, which is 84 over 8 is equal to m. 84 over 8, we can reduce that as a fraction, or we can change it to a decimal. Either way, we either get 21 over 2 is equal to m, or if we want a fraction, that's 10.5 is equal to m. Okay? Let's try another one. Okay? This time, the variable is on the left-hand side. So x over 7 is equal to 4 over 5. I'm going to multiply both sides by 7. The 7's then cancel, right, to get the x by itself. So that's 4 times 7. So that's 28 over 5, which does not reduce. But if I wanted to, I could change it to a decimal with my calculator. Okay? So that usually works if, notice where the variable is. The variable is on the top. But it doesn't always have to be on the top. So we have another property which is used much more in proportions. And you've probably heard of this one before. So in the proportion A over B is equal to C over D, the products AD, A times D, and BC, B times C, are called cross products. Notice that they are across from each other. You can use the following property of cross products to solve for proportions. So the cross products of a proportion are always equal to each other. So notice in the red, A over B is equal to C over D, and in the red we have A and D. In the blue we have B and C. And as long as B and D are not equal to 0, then A times D is equal to B times C. For example, 3 times 12 is equal to 4 times 9, both 36. And this is a pretty useful property to solve proportions. Let's see why this actually works. And this is a proof. Okay? So we can use the multiplication property of equality to prove the cross products property. Okay? You get to do a lot of proofs next year in geometry, but here's a pretty basic one. So if we assume that our starting equation is equal to true, A over B is equal to C over D, we're trying to show that the cross products are equal to each other. Well, I can multiply both sides of this equation. As long as I multiply both sides of the equation by the same thing, I can multiply both sides by anything I want. So I'm choosing to multiply both sides by BD. Okay, the B's cancel on the left, The d's cancel on the right, and that leaves me d times a is equal to b times c, which I can rewrite with the commutative property any way I want, and I chose to just flip them around, or flip these two around to give me AD is equal to BC, which happens to be my cross products right there. Okay. For this particular proportion, A and D are called the extremes of the proportion, and B and C are called the means. Notice that the cross product property, notice that in the cross product property, the product of the means equals the product of the extremes. Okay. So a little vocabulary to help us out. Okay. So now let's look at this problem right here. So in this proportion, I can't just multiply equals 8 over x. I can't just multiply both sides by 8 because that won't cancel out the 8. So this is a perfect problem to use my cross products property. So I'm going to multiply A and D. I'm going to multiply the extremes. So I'm going to multiply 4 times x to give me 4x, and 8 times 3 to give me my right-hand side. So this turns into 4x is equal to 24. I'm going to divide out the 4 to solve this equation, and I'm going to get that x is equal to 6. Double check yourself here. I have my answer 6, right? So that's going to go down here. Notice that 4 is bigger than 3, 8 is bigger than 6, okay? My answer does make sense. And if I were to reduce it, I would actually get it to work. So next, with our Gongora problem, what is the solution of the proportion y over 3 is equal to 3 over 5? So we're going to do that the same way. We're going to cross multiply and then divide. So it turns into 5y is equal to 9. And in this case, when I divide out the 5, y is going to be equal to 9 over 5, which does not reduce. So for this reasoning question, would you rather use, would you rather use the cross products property or the multiplication property to solve this equation? Well, because the variable is in the bottom, we're going to use the cross product property. Make this a lot easier. We could change this equation around and then use the multiplication property, but that's just more chance for a mistake. And in fact, any proportion that you see, you should get in the habit of realizing that you can just use the cross products property. Even with my first one, okay? I could, if I wanted to, multiply 7 times 12 to give me 84 equal to 8m, cross products. Divide both sides by 8, and notice that I get the exact same thing as before. Okay, so get into the habit, if you see a proportion, to use cross products, especially if you have a proportion that looks like problem 3. So this is a multi-step proportion. Not only is cross multiplying the best way to solve this, okay, it's probably it's going to be the most efficient way and probably the only way that you could actually get to the answer. Okay, so we're going to cross multiply. So we're going to start with my equation, b minus 8 over 5 is equal to b plus 3 over 4. I'm going to multiply these two together first. So that's going to be 4 times b minus 8 equals these two multiplied together. So that's 5 times b plus 3. Okay, now distribute. So that's 4b minus 32 is equal to 5b plus 15. And now we have an equation with variables on both sides. So if you remember back to the previous lessons, is that we should always try to keep my variable positive. So I want to bring the smaller one to the bigger one. So I'm going to subtract 4b from both sides. That gives me a negative 32 is equal to b plus 15. And then subtract out the 15 to isolate the variable. And I get negative 47 is equal to b. Okay. Tough to just double check yourself here because we're plugging it back into the equation, right? We're not solving for the answer on the top. All we're doing is solving for B in this case. Okay. Let's try another one. So what is the solution to the proportion n over 5 is equal to 2n plus 4 over 6? So cross multiply. That gives me 6n, n times 6, is equal to 5 times 2n plus 4. So now we have 10n plus 20 when I distribute the 5. You could bring the 6n over to this side because it's smaller. It's going to keep it positive, but don't forget, then you're going to have a 0 over here. Probably still the most efficient way is to just move the 10n over here, even though that'll give you a negative 4n is equal to 20. Divide out the negative 4, and we get that n is equal to negative 5. Okay? Cross multiply, solve the equation. Okay? So when we model real world situations, which is really where proportions are used most often, we must write the proportion very carefully. You can write the proportion so that the numerators have the same units and the denominators have the same units. So notice, this one's correct. Miles, miles, hours, hours. This one is not correct. Miles, hours, hours, miles. So the stuff in the numerator has to match the stuff in the denominator. The stuff on the top has to match the stuff on the bottom. Okay? That's a way to check yourself when you are actually setting up the proportion. So a portable media player has 2 gigs of storage and can hold about 500 songs. A similar but larger media player has 80 gigs of storage. And how many songs can the larger media player hold? Well, if we set this up, we could set this up as 2 gigabytes over 500 songs is equal to, I'm going to put the 80 up top so that way they match. Now, is this the only way to solve it? No. I could have put 500 on the top, 2 on the bottom. Now I just have to make sure that the X goes up on the top and the 80 on the bottom. Gigabits, songs. So just make sure that the stuff on each level matches. So it does not matter which way you want to solve this problem, because when you cross multiply, you're going to get 2x is equal to 540,000 with this one. And same thing here, 40,000 is equal to 2x. Okay, and that is the reflexive property that they are both the same thing. So divide out the 2, and we have that x is equal to 20,000 songs. Okay. Same thing over here. Older textbook, now we can hold much, much more. And most of the time you're just streaming your songs anyway. You're not loading them onto a media player or your phone. All right, so 8-ounce can of orange juice contains 97 milligrams of vitamin C. So I'm not so worried about the units. I just got to make sure they match. So let's call that 8 over 97. Okay, so that's ounces, and that's milligrams. Okay. How many milligrams of vitamin C are there in a 12-ounce can? So I'm going to put that on the top so that way my units match. Cross multiply, 8 times the x gives me 8x. 12 times 97 gives me 1164. Divide out the 8. And we have going to be a fraction. So we're going to get a fraction or a decimal. In this case, probably better to use a decimal. 145.5. And that's going to be milligrams. Does your answer make sense? Sure. We have a bigger can, so we're going to have more milligrams of vitamin C. Okay. All right. So solve a proportion Make sure we know how to do all this with our lesson check. Solve a proportion with this one. You can do either method you want. You can multiply both sides by 6, but still, I would just get in the habit, if you see a proportion, if you see an equal sign there, cross multiply. Same thing, cross multiply here, here, and here. This one especially, these two especially, make sure you're careful. Uh, 4 is a little bit easier because there's only one variable as opposed to 3 where there's two. For number 5, a band went to a recording studio and recorded 4 songs, 3 hours. How long will it take the band to record 9 songs? So that's 9 songs over X hours. And then solve that. Identify the following, the extremes. Okay? To find the extremes, we're always going to start at the top and cross down. So the extremes are MQ. The means are PN. And the cross products are both of them. So that's MQ and PN. Okay? When solving this equation, Lisa's first step was to write 4x equals 5 times 3. Jen's first step was to write 20 times x over 5 equals 20 times 3 over 4. Now, obviously the first method is going to work because that's what we've been talking about. But will this method work? And the answer is actually yes, because it will clear both fractions. Okay? You multiply both sides by the common denominator to clear any fractions that you want. Okay? So in this case, we're still going to be left with the 20 and the 5 reduced to 4x. These two reduce to 5. So we still are left with 4x is equal to 15, which is exactly what we have there. Okay. So that was 2-7, solving proportions.